introductory words. I have not rehearsed this talk at all, and I was writing it until about an hour ago. So it's as in the finest traditions of poetry. However, it does use lots of nice fonts. So and I've put in some graphs, so it looks quite pretty towards the second half. Right, I think I am meant to start now. So let's work on that assumption. So who am I? I am Tim Retout. I am the development manager at CB Library, so I manage a team of 10 or so people working on our very big job board, doing lots of features and bug fixes, and we have something like 3 million users monthly, and we're hiring. So there we are, and the summary of this talk, if you want to go and catch it on Dickens, is if you release your features to everyone at once, that's a very high-risk strategy. If you can do it a bit at a time, so either to a small group of users that you've chosen or to a percentage, then that's less risky and therefore better. And the second part is you need to get feedback on whether those features are working. So that's the summary. Now the secret to this talk is I actually wanted to do 2 talks, but I'm quite lazy and don't want to write 2 sets of slides. So what I've done is I've combined them into one, and they're sort of loosely coupled. And they are related to each other in the sense that these are both things that can help reduce the risk in your release process. But let's start with this one. So this, the feature toggles idea is very simple actually. I think it was first invented at Flickr, or they were the first to write about it. So they were actually using Perl, but they came up with this. And it's very much like a big if block around the code that you're turning on and off. I mean, that's exactly what it is. But rather than hard coding the decision about who to turn it on for, or about what percentage of users, or having nasty randomization things actually in your code next to the feature, you can store those decisions in a database or in Redis, and separate those things in your code base. So this is very, very flexible. Let's go to it upstairs. It's very flexible because you can tweak it at runtime. You don't need to deploy it to another machine. You don't need to worry about maintaining multiple versions of your code base on different machines, or multiple code bases on the same machine, sort of balancing between those. That's all very complicated. With this approach, you're just tweaking a value in a database. And at runtime, the code decides, hey, this user, is this feature turned on or not? And that's actually a very, very powerful idea. But incredibly short amount of code, hence I was able to write it, in fact, steal it. As we'll see in a moment. So, we can reduce these risks. We can avoid great big long-lived branches with a crashing merge at the end, because what you can do is you can get your developers to first put in the feature flag, put in the F block, they build up their code, so they hack away, committing almost to master. I mean, you still have to do QA. You still have to check that you're not going to introduce the compilation error, for instance. But hopefully, you can do this at a time. You can get, it's not literally every commit goes into master untested, but it's more like you develop a chunk of the big feature. You get that tested, you get that merged, soon after you write it so that it renders cleanly, but it's hidden behind this feature flag, and it doesn't get turned on until you decide that it's ready for the wide world to see it. You can roll out code percentage, we mentioned. Performance testing. Performance testing is such a difficult problem, and I'll speak about this in a minute. And rolling back is really simple as well. So here are the downsides. In the interest of full disclosure, it is some more complexity. It's not as simple as if you've got a small feature, you might not want to do this. If you've got two implementations of the same feature, say one older, one newer, then yes, you're going to have code duplication for a time because you're running both in production and choosing between them. There could be a testing effect, so if you are unwise in your use of these, they're essentially if blocks, you could end up with one feature affecting another, and that would be a nightmare because your testers would have to test every combination. Don't do that. That's quite right. Runtime performance impact. Obviously, you're hitting a database to check whether the feature's turned on. So if this is in a very tight loop, in a code path that's run many times a second, then you're going to hammer your database. So do be careful about that. We have done some things, maybe I'll speak another time about how we dealt with that, just as caching. And once you've written the feature, you probably want to go back in and put out the if box. So it's not all plain sailing, but to help you, I have lately worked on a Ruby library which does exactly this. I ported it almost line for line, and like all the best things sometimes. And we put it on CPAN, and it's called Toggle. As you can see, it's got a very high version number, so very confident, of course, in this game. But actually, it's got good test coverage, and we do use it. It's not for all of them. So I want to show you a little bit about how you go about using this sort of in practice, and maybe I can tell you what we use it for. So there is a bit of setup. So a bit of setup to get going. You probably only need to do this once in your code base. Hopefully you have a convenient place where you can initialize big things you're going to use, about tiny things you're going to use. So in this example, I'm just constructing a Redis object and shoving it into Toggle, and then we've got the object, and that's built. So typically this might be if you're in a more Perl environment, it's in your startup here. We are using breadboard, which I'll talk about in the languages. And this means that you can get hold of that build object anywhere in your code that you want to use it. So once you've got that sorted out, it's really easy. I should just mention the Datastore, because we've said Redis here. We're not limited to Redis, so you notice that that's been injected there. At CPAN library, we actually wrote a different implementation that used the batch onto MySQL, just because we were short of time and didn't want to deploy Redis. So that's quite easy to swap out. And then in the database itself, it's sorted a little bit like this. You've got the name of the feature as the key. I'm not sure that this is actually the internal representation. We might have a namespace on it. And then we just shove all of the bits that we want to know about the feature into the value. So we've got the percentage of users we're rolling up to, a couple of usernames, and some groups. You can have multiple groups. So this is not exactly normalized. I accept that. but this is for performance reasons. You only need to do one row lookup when you're doing a check. So that keeps the checks relatively quick. I think the database is going to be the bottleneck on any of these decisions. And as soon as you see that god-awful database format now, you ask, is there a user interface? And no, there isn't. There should be, but again, I'm quite lazy. So this is what they have in the Ruby. So someone has made a pretty user interface, and you can select for every feature a percentage, some groups, and some individual users. And a lot of this, all of the features that are required in Toggle itself are there to build that. So hopefully someone's going to come along and do that for me. Otherwise, at some point when we get bored of updating database columns manually, we will do that. We did actually build something internally that has pretty sliders, but it's not ready for current time. Cool. So the idea would be you give this to the person who cares. You have a nice name for the feature, and so the business person, it could even be a business person making the decision, hey, we want to roll this out to 10% now, these are the numbers, I can see them, so they click the drop down, and away we go, and that would happen instantly in real time. And if there's a horrible problem, then drop all of that to 0 and it will roll back. So in your actual code, you do this sort of thing. It is an if block. I'm not quite sure. I couldn't quite justify a 50-minute talk about if statements, so there is some more graphs in there. So if this feature is enabled, then we have this extra code. But that in itself, while that will work, that's not enough for you to make useful decisions about whether to show the feature. That just says offer on. The way that works is if you put the percentage up to 100, then that will go on, otherwise it's off. So what you actually need is to pass in a user or some sort of account object or something a bit like that to you give that to Toggle, and Toggle can make a decision for you based on the rules you set. So in your code, you don't have to make any decision about the user or about the account. That's all behind the scenes. And then magic. So the simplest, one of the simplest cases would be early in the process you went to get staff to do some testing on the thing you've just written. So this bit of code here, this defines a staff group, and this would be again somewhere near the initialization code, or you could write a subclass of Toggle. And you make some sort of decision based on the object that gets passed in, and return true or false, and that tells Toggle whether the user that you passed in the code, tells them whether that user is in the group that it's asking about. Then what you do is, for the chat feature, you put the staff group into the database, and boom, all staff get the chat feature. Incremental rollout is very similar, so you don't even need to define a group for this to work. You just flip the switch on the percentage up to 1%, and then as you gain confidence in your feature somehow, then you can manually increase that percentage. So this is how small companies like us can't be more like Booking.com with 800 machines.
Doesn't this mean that over time, all your users will get the feature?
Yes, it's within your control. So as you increase the percentage, it will roll out to everyone.
But what I'm trying to say is, if I just hammer say a system, and it's going to roll the dice, eventually I'm going to be in that 1%.
It
Right?
optimizes once for you. Once it's rolled once for you, that's it.
Okay. All
There's
right.
termination information.
Okay, that's the
Yeah, so this is exactly the second bullet point here. So we take the user ID. Now, in the Ruby code, it hard-coded a call to the ID method on the object you pass in. I can't remember whether we've removed that yet, because that's slightly inflexible. So it's a deterministic hash of the ID. It takes the modulus of that, modulus 100 thing, and then checks whether it's less than the percentage you set in the database. So once you get a feature, you keep the feature. So it's a check every time. Every time the user passes through that if block, it will hash the ID, check if it's turned on, and then then just that percentage of users should be getting the feature. I'm actually very interested in what booking do, because I'm sure that's something like this. We'll talk at the end.
Does that mean that it's always the same users who get to try new features first?
Yes, that is the weakness.
Typically what you do is you include the name of the feature in the hash as well.
Yes, unfortunately I ported the Ruby library line for line, and they didn't do this. So we're now in the process of discovering all the things that are horribly wrong with this model, and that's exactly one of the ideas we have. So my next gambit might be to find another Ruby library that is also very popular. I believe GitHub have one, and then see if that's any better. I mean, this originally started where we were trying to steal all of Etsy's ideas from their blog posts, and this was one of them. So where we went, and since then we've branched out. We're trying to steal ideas from lots of other companies.
What we do at Booking.com is something not entirely dissimilar from this, but we don't need a database. We're able to resolve all of this with just a single state variable that's associated to every user.
Interesting. I think we should talk more. We should talk more about that, because I can see that this might not necessarily. I don't know. It might scale. It might scale. You never know. Right. So rollback. What do we think? Rollback's easy. Set percentage to null. So the nice thing about this is you don't have to deploy again. So we're in situations where we would deploy a feature and then have to do a git revert and then deploy the inverse change and hope we can do that quick enough before anyone notices. Now we have, if it's a sufficiently risky feature where we do this, then you deploy the code with the feature turned off. That's the crucial bit. And then turn it on a little bit, and then a little bit more, and then, oh crap, there's a problem, and we can roll it back. I mean, depending on how usable the feature is, that's an option. Cool. And what the question I get asked most often when I talk about this actually is about people start to think immediately about preferences and just configuration settings and labs experiments. Like they have on Gmail. So for labs experiments, I think this is a valid option. I've been thinking about it, but only really if you're planning to release to all users later. So if it really is an experiment that you're trying to find out if people like it, then this could work. But you would want to do it by creating a group rather than sticking IDs into the toggle database, because you saw before that just would end up with a common separate list of IDs, you'd end up with thousands in there. That would not scale, it is not efficient, whereas if you use a group it will be relatively efficient. So that would work, but if it's just a preference, a preference panel, I don't think this is the library for you. Right, so graphs. Before I move on to graphs, are there any burning questions about toggle before I move on? Because I could, yes.
quite sure how the percentages interact with the IDs interact with the groups.
Right.
Is it that you have to be in one of those three, and if you set the percentage to 0, does that definitely override the other two?
The users, I think, users and groups trump the percentage. These are all ways of getting into the feature. So you only need one of those three to match in order for the feature to be turned on. So I think that pretty much explains it. It's not entirely. It's enough flexibility to do a rollout.
I was just going to quote another example. So, I mean, coming from Google, that's very much what we do there. In that you'd start we call it an experiment, but you'd build the experiment and you would just put yourself in that experiment and just play around with it, knowing that nobody else in the world is going to be affected by it. And then you decide, add a few more developers, then eventually you might add your entire project team, and then eventually you start rolling it out, so you push it to sort of say 10, 20, 100% to Google, and then start rolling it out to production. That's very much typically. So it's always a union. If you satisfy any of these categories, you can have it.
I don't have a way of doing a percentage of a group right now.
Useful thing to have.
Yes.
Don't you guys do line sequence experimentation?
Sorry, how do you mean?
Oh, that's
It's called out.
Part of the reason for having this talk and bringing it here is that I love stealing ideas. Give me more ideas. I'll steal them. Right, graphs. Again, graphs are lots of people do graphs. And I was very interested in the last talk about Booking's event logging system, Hadoop and all stuff, which is going to kick the arse of all of this. Because I just stole this from Etsy, right? And this isn't even a Perl talk. But it does a lot of promise time. So what we do is we have we're using StatState and graphite to get near real-time graphs, 10-second resolution. You can tweak that a bit more, but obviously there's a performance thing. And we want both application level metrics and server level monitoring. So here is a graph of the number of graphs over time. Up to the end of October, something like that. So we're quite keen on this graphs. As you get a bit of jigsitch, right? So right.
At what point on this graph does it count itself?
Yes, I don't know. I think so. This is actually the StatsD numbstats graph. So I think strictly this is a graph of statistics, not a graph of graphs. Because you can then combine the stats to make more graphs like this one.
What do you feed your metrics into? What do you use for graphing?
Yes, we are using graphite.
That's the
Stickers don't like that.
Was that me? Did I do something?
No,
I did.
I think it's random.
Okay, yes. The technology we're using here is StatsD and graphite. The way this works, I haven't done a diagram here, which I would find really helpful, so apologies for that. Your code sends UDP packets to StatsD, and StatsD aggregates all the packets and then sends them to graphite, and graphite is the thing which then does the graphing. The reason it's using UDP is because this is just stuff for monitoring. I mean, we don't need 100% reliability here. It's surprisingly reliable, actually. I don't think we have that many block packets, but we don't want the code to have a block on trying to get a result into StatsD. If StatsD falls over, we don't want the code to go down. That would be, the opposite of what we want.
We do the exact same thing at Booking, by the way, with the jets.
Excellent. And again, I do want to steal those ideas. Right. So what this looks like is so you're adding lines of code. So there's library or many libraries on CPAN. We're using this one. It may or may not be the best one. I would make your own decision. And we just put a wrapper around it. And so in our code, we just have lines like this. So we're incrementing a counter. We're putting in the name of the counter. We can also programmatically calculate the name that we want. So you see this when we're doing an A/B test, for instance. You can have A and B, and it will count them all. So you put this all over your code, and suddenly you've got amazing visibility into your platform. And then you freak out at the number of spikes. I mean, Jesus. This was our homepage. And so another thing Statsty and Graphite do really well is timing information. So we like benchmarking and profiling, but it's not actually the same as seeing how your code is performing on production in real time. Because this is the home page, this is the page response time of the home page, and if you look at the numbers up here, the scale is 125 milliseconds is that spike, so actually it's still pretty fast. And if you saw that headline figure, 125 milliseconds, you might not worry too much. But when you see it on a graph like this, you're going, oh, spike, you get rather worried. So we dug into this, and then we found these spikes are actually once a day, but in there, at a slightly lower resolution, there was a spike every 2 hours. And we dug into this, and then we found a cron script buried in our systems somewhere that is every time I touch this table, so I'm just not going to do that. We found a cron script that was restarting manufacturing.
So this is the median of every 10 seconds, right? So do you also have like the 99th percentile?
Statsty does the 90th percentile. I don't think we have the 99th. We have an upper. Jesus Christ. we have an upper and a 90th percentile. So just to, I think the other really interesting thing about this that I'd just like to mention is that when you're debugging an issue, so I was doing this last week actually, we had an issue with the job view page loads starting. We noticed that those started getting to be really time. And it's actually possible to add these lines of code as you're debugging and actually get those deployed. So then you have new graphs arriving all the time, sort of to try and rule out possibilities for what could be the cause of these timing things. And we actually used that the other week to track down something like a 10-second job view pages jumping up to 10-second latency at the 90th percentile. So this was pretty amazing. I mean, this is actually a graph this morning. This is the last 24 hours, I think. And I actually don't know what that is. I don't know what that is either. But there you are. So that is the median page load time, and this is the 90th percentile time. So it looks horrendous, right? We've got loads of work to do before we can sleep easy. But I think the point about this is I saw a talk 2 years ago at FOSDEM about monitoring, and they were saying there's this difference between active monitoring and passive monitoring. You've got the active monitoring like Nagios, where you're polling the status of your site. You might poll a page and get back a response time at a particular point in time for a particular request. But this is passive monitoring. You've got it happening on every page load on the site. You're sending out timing information for every page, stick it in a graph, and then suddenly, oh shit, what's going on? Yeah.
That's 5,000 seconds, right?
Statsty always uses milliseconds.
Oh, right.
So no.
They should use it. Not much better, but
Yes. So what this actually means, I suppose the way to read this is that 10% of our users are having an awful time. Yeah. I'm really sorry.
must be a good product.
Oh, yeah, well, it is.
But without drilling into it, for all you know, that's a bunch of robots hitting you from China over a slow connection. Like,
So it's not measured. This isn't the JavaScript measurement of the page load. Yeah.
sorry.
It's time that it takes to respond on the server, not the time from the client.
It
If
could
the
still.
client's accepting its data back really slowly, then it's going to take a long time to render. and push
Oh,
it.
I hope you're not timing it off for that thing, because that should be down to web servers socket to flash it, not.
But if you're not timing how long it takes to get to the customer, then you're not timing when the customer
Yeah,
sees.
that's the thing.
We will measure that as well. I think we do measure that as well for some pages, but that's not this graph.
That
So
would be in StatSteve, I presume. That would be somewhere like Google Analytics or something.
you can do it with Google Analytics. They take a sample and you can see average page load time. But yes, you get the effect where someone from China is going to have a slow time of it because they're going around the world. This has been a lot more useful to us.
The power plant is just down there.
Sorry, how do we stop this happening?
Well, I'm not certain, but it looks like a wires loudspeaker. Just down there.
I hate hardware. I don't want to. I just do software. Please. How are we doing for time?
20 minutes.
Great. Okay, so I've only got a few more graphs to show you, so I've got to drag these out a bit. This is drilling in. So this is 24 minutes. I often end up looking at graphs which are 24 minutes long because you have a selector which says 24 hours and then you change it to minutes. So anyway, so this is. But you can see here that the resolution on these stats is really to the 10-second level, which is enough for the times we have. So that is, and this is just showing again the same time interval, comparing the median time with the 90th percentile time. So this is actually pretty good. Everything's under 150 milliseconds. These dips here, I think, are to do with some sort of experiment involving memcached that is going horribly well. But then if you look at the 90th percentile, you have these nasty spikes. I say nasty, the page still comes back in under a second and a half, but then that's 10% of users who have a slow page load. And you can actually break it down in here by the particular part of the page. We're timing parts of the page like the service on the back end is actually fetching out the query and doing some matching. We've got the template loading is the red bit, so that's so we have that's the sort of thing. This is the level of debugging that we need to actually pin down the cause of performance issues. And one last thing, just to bring it back in tangentially related to releases and deployments. It's very easy to plot lines on graphite when certain events happen. So in our Jenkins job that deploys the code, we've stuck a shell one-liner or something that hits graphite and tells graphite there was an event at this time. So these black lines represent the time that we deployed our code over the course of whichever day this was. So we only did 6 deployments that day, so pretty bright. And the idea of this would be that if you have a sudden spike on your graph that happens after you deploy something, that you know that it was probably that one that caused an issue. But that actually changes slightly when you're using toggle with this, because you then have to have a graph of when you increase the toggle percentage. So that was one of the first things we did actually, was you can for every feature graph the percentage of people you've rolled out to, and then you get a line that's like a square steps. You can see when things start to go horribly wrong. And just for completeness, because I realised just before doing the talk that I hadn't actually included a graph of counters. I got so carried away with timing information that I hadn't shown you how to count things. So this is job applications. How many job applications appeared at every 10-second interval? And so we can see that, daytime is busier. Again, I don't know what that is. Hopefully that's just... Yeah, hopefully that's not too bad. So we've got a quite nice curve going on here. Oh, that's a moving average. Just so you know, the blue line's moving average. Graphite has loads of built-in functions. So you can do things like integrate over this curve and see how many job applications have appeared since the start of the day. So that's really useful for fetching out metrics for dashboards and things, because it's nice and real time.
But those functions are terrible at the leading edge.
Yes.
All your graphs will look like everything's going to 0. So you need to ignore the right side of the graph, which is then bad to train people with.
Yes. Integration isn't so bad, but moving average can be. Right, so let's just run through the last couple of things. These are sort of opportunities for extension that we're sort of just starting to do, but can't really tell you whether they work yet or not. So we added A/B testing in the second release of Perl, because Etsy had it, and so we started from theirs. So then the idea would be that you have 2 sets of users, 2 variants, and you graph both of them and check the metrics, see which one performs better. Then hopefully you can make a decision about how to roll out different versions of your feature. We mentioned, I said I would say about performance testing. So I guess that is around the job view graphs that you just saw, that timing information. There's no reason that you have to just be graphing the job views across all users. If you combine this toggle, you can plot graphs just a subset of users. And in fact, I think the job view graphs are actually only people who are not logged in a lot of those. Because when people are logged in, we do lots of extra work, it takes a lot longer. So depending on what you're interested in, you can put 1% of users through graph tool, and then you'll be able to decide whether your service would actually hold up under the load. So here's another one which I haven't started yet. So this is the same guy who wrote the Ruby rollout module, and he wrote another thing called degrade. And the idea of that is you hook your monitoring into some kind of you put a threshold on the number of errors that a particular service can produce. So if you have a non-critical thing, like we have a service which adds logos and CVs, which isn't the end of the world if it doesn't happen. If that's throwing up lots of errors, you could automatically turn it off by telling the code to send the feature flag down to 0. So that would. So I don't know how well this would work in practice, and obviously it's a lot of risk where you could turn off your website. So here's one last idea that I have not implemented yet, but this would also be really easy to work, which is if you are doing a new implementation of a piece of code, then you can stick both function calls in a single block, run both paths for a user. You have to make sure they're non-destructive. Then you throw the new results away, and then automatically put graphs in of how long each code path took, and if there was a difference between the results that came back, then throw a counter and increment that, and then graph that. And then you should be able to compare over time how well you're approaching being able to reach the right result. And this would be useful for mission critical things where you're obviously going to put it through testing, but you want to also make sure that all of the rubbish code, the data in production is that you're catching every edge case. and you should see, hopefully, your counter of differences going down to 0 every time, and the timing information will stay within whatever boundary you deem acceptable.
Is caching going to have an effect on the timings of the second case versus the first time in that situation?
So that's yes, potentially, all sorts of things.
Second one's always much faster.
Like yes, it might
Yeah,
go
when I swap them around, then you wonder.
So the GitHub module has, by default, it randomizes the order that they run in. So that if you've got things like the disk cache or whatever is involved, then hopefully that will get averaged away. This looks really interesting stuff. I can't wait to get a chance to code it up. So, in summary, we are. I think this type of activity is one of the best places that you can put your fun experimental development time, because it's almost legitimate, right? You're actually working on reducing risks in your development process overall. You're reducing the risk when it's actually on production. You're finding new things to be scared about in your operational platform. All of these things, and the follow-on ideas like new ways of testing your code, new ways of measuring the performance in detailed bits of code on production hardware. This is the gist of continuous improvement, in my view. So, graph's cool. Everyone should do stuff. I think that is it. So, if you already do something better than this, then please come and talk to me, or send me an email, or publish your source code. That would be the best one. Because I'm hoping to steal all these ideas from Ruby and
Do you apply this toggle feature for bug fixes?
It probably depends on the bug fix. I would say no in general. I mean, we're quite new at this. You would end up with, you have to be really careful not to end up with a whole tangle of different blocks separate. So we're quite targeted in how we use it. It's only for features for us. But as we gain experience, maybe there's something we can do.
I think you should try it. We've had some really surprising results with stuff like that. We've had bugs that we know are bugs, right? We tried it. The customer hates it. They like the bug.
100% discount, but
They love it.
Well, obviously we're not gonna leave that kind of bug alive. But like if it's something that this box is getting laid out 10 pixels to the left, and all the designers say like yeah, it should be over there to the right. And we try and experiment and see if moving it to the right actually helps. And sometimes it really doesn't help.
The joy of feature testing. There are lots of opportunities for extension here. Like I've read about people doing graphing. All of these stats you saw, those are just across our platform. Now we only have like 2 application servers, so that's generally not too worrying. But then once you get many more boxes, if you plot the graphs on a per box basis and then aggregate them carefully, then that gives you the raw information when you need to drill down to the problem. You can see, does it affect just one box, or does it affect them across the board? And then you get into the sort of, I think Anglia does this well. There are other tools, but this has been pretty good. We've had some pretty good wins with this software.
So this isn't really a question, it's more of a warning. We used to use graphite for some graphing. When we switched to Switch, we added Splunk, and then we found Splunk didn't do everything we wanted as well. So we added Logstash Cabana, as a lot of people have. But we were doing the same thing as you. We were chucking UDP at it, and it turns out that Ruby for it shits the bed very, very badly when you chuck billions of requests at it. So you have to make sure you configure Logstash to chuck the threads through the roof, if you're going to chuck loads of UDP packets at it for graphing. Kibana's really good, it's really fast, but just a warning for anyone that's trying out different aggregation and graphing modules that when you get to the inevitable log stash, chuck the threads up.
I can tell you 2 quick anecdotes about this. The first one is we had a weird spike in our job search timings that was happening every 5 minutes. And we looked into it, dug into it a little bit more, sort of tried lots of things. Turned out it was the Moonin graphs generating stats of solar. So graphs do sometimes cause problems, but the good news is that the answer to that problem is more graphs. So that's the first one. The second one is you get quite addicted to this. I put in a statsy line in one of our programs and sends email. It sends quite a lot of emails, sends them quite fast. And there's a feature in this. There's a very clever feature in statsy that does sampling. So you can put in the code that you only wanted to go for 1% of requests and so on, and it will automatically scale the numbers so that the answer comes out right at the end. And you just don't have to do anything, you just put the number in. Anyway, I didn't use that feature correctly. So then we had one of the sysadmins came into some special later today saying, this server is getting DOSed by the cron server. What's going on? And it was sending trillions of UDP packets to not quite, but lots of UDP packets at the launch server. And I actually had a graph of it, but it went through the roof. But the good news is that sort of stress test of the platform showed we have a lot of room for growth. But the moral of the story is that you can seriously break things with this. It's not necessarily zero risk. More questions? Yes.
How long is it sort of taking you to get to where you are with this?
Oh, well, we started about 3 months ago or so-ish. We moved pretty quickly. Literally, I struggled to dig the graphs out because they don't go back past about September or so, August, September. That's when we had the first ones in. But the flip side of that is you get so much information comes up that your day seems to move much faster because you've got all these problems flagging up. And so it seems like a really long time, but in real terms it's not. Yes?
Do you do anything for categorizing types of requests, so by what they're doing, so that you can separate out whether you're seeing an average that's pulled up or down by something?
We do a bit of that, but we have to think ahead. So the only one I can think of, the best example is where we have logged in, logged out users, because we know that those are doing different things.
It's one of the things I found Graphite wasn't very good for. Splunk's much better than Kibana for it, is just being able to say, show me the graphs by user or by what service they're using or whether or not they're printing something. Or
yes, we also have Logstash. That's more for
Kibana doesn't do it.
log data.
We use Graphite for that.
Do you?
Yeah.
I'd be interested in.
I mean, we produce something like 500,000 metrics a second. So our Graphite setup is.
You never have too many graphs. Oh, you
I don't
can.
know, 40 boxes or something. We're rewriting all the storage there and all of that. Booking's really invested in Graphite.
Yes.
Sorry.
Yeah.
Going back to your user toggling.
Yes.
And somewhere there's a user who's always in the first 1%. And do those users know what's going on? And how come I get all these good features?
Right. The thing about these incremental rollouts is every user is going to get every feature in the end. So hopefully they don't notice, they just get the feature a bit sooner than the other people. Depends how you do it. And yes, we do need to solve this problem of the ordering possibly. Maybe, yes.
Have you got negative groups? So if you have 100% on your percentage, could you have a negative group, say like an opt-out?
No, we don't have that, I believe.
Almost using it as like a user preference for features, as in, yeah, no, I want no part of this.
So that would be, yeah, that, and I think that ties into the percentages for groups idea. So what I need to go and do is, because we're on version 0.02, need to go and steal ideas from lots of other places. That's my plan. Right, how much time?
That's about time, actually.
That's about time. Sorry about that.
Unless there's one too more.
Well, I can answer questions. It's time for the break.
I'll be great.
If you want to talk to me, obviously do all of these things. So thank you.